This video is going to be about the Pythagorean identity. Most of us have heard of the Pythagorean theorem, a squared plus b squared equals c squared. But this video will help us see how this relates to our trig functions. The unit circle is going to be very important in deriving the Pythagorean identity. Here's a picture of the unit circle. Here I've pulled out a random triangle of the unit circle just to demonstrate again that we have an x length and a y length for each angle. Please remember, the x is cosine, the y is sine. The angle has been labeled as theta because this works for any angle on the unit circle. Could be 30, 45, 60, any angle. So let's see how the Pythagorean theorem can actually help us learn some interesting things about our trig ratios. So for any right triangle, we know that one side squared plus another side squared equals the hypotenuse squared. So let's just write in what we have from this triangle, which is a blow up of a unit circle triangle. So I'll just pick one of these sides. I'll say y squared plus x squared, so my two legs squared, added, is going to equal my hypotenuse squared. And my hypotenuse, since we're in the unit circle, my hypotenuse, or the radius of the circle, has to be 1. Now, it's really important to remember that y equals the sine of theta, and x equals the cosine of theta. So I'm going to actually replace x and y by sine and cosine. So I now am going to have the sine of theta squared plus the cosine of theta squared equals 1 squared, or simply 1. Now usually when you see this identity written out, you'll see it actually written with the square between the sine and the theta rather than the sine with parentheses and then squared. These mean exactly the same thing. And it's important to recognize what this notation means. Sine with the square and then the theta. It just means find sine of the angle, then square it. And actually here, we now have our Pythagorean identity. Sine squared plus cosine squared equals 1. So let's see an example of how this can actually help us. So in this problem, we're given that the sine of an angle, we don't know the angle, and we honestly don't care. So the sine of this angle is going to be 0.6. So let's see what our Pythagorean identity can help us do. So I know from the Pythagorean identity that the sine squared plus the cosine squared of this, whatever this angle happens to be, has to be 1. Well, I know the sine, so I'm just going to plug that in here. So I now have 0.6 squared. I just replaced sine squared with 0.6 squared, since sine equals 0.6. So plus the cosine squared equals 1. Now my goal is to find the cosine. So I want to get this cosine part all by itself. So I'm going to subtract 0.6 squared from both sides. Now if you evaluated 0.6 squared first and then subtracted it, no problem, but I'll do that later. So now I have that the cosine squared equals 1 minus 0.6 squared. And now I will do 0.6 squared, and I will see that that equals 0.36. So 1 minus, this part becomes 0.36, so now I have that the cosine squared of my angle equals 1 minus 0.36, which equals 0.64. Well, I wanted the cosine, but now I have the cosine squared. So to undo that square, of course, I'm going to take the square root, But as you guys, I hope, remember from the quadratics unit, whenever I take the square root like that, I actually have to insert this plus or minus. There's two values that could give us that cosine squared. So plus or minus 0.64. I can go to my calculator now and do the square root of 0.64. And I'm actually going to see that the cosine of this angle equals plus or minus 0.8. So please, please, please notice we actually have two answers. The cosine could be a positive 0.8 or the cosine could be a negative 0.8. The next slide is going to show us from the unit circle why this actually makes sense. So here's my unit circle. If you remember from the last example, we were given that the sine of the angle equals 0.6, and we were asked for what is the cosine, and we got two answers. We got that the cosine of the angle can be plus or minus 0.8. So let's see why that makes sense. Looking at this unit circle, we will remember that sine is the y. So sine is on the y here. So 0.6, if this is my y, well, this is 1. So 0.6 would be just above 1/2 or so. So it's not too important where I put it. But let's say it's right there, 0.6. If I'm looking for corresponding x values, well, I can go to the right and find one right here. We'll say that's 0.8. Or I could have gone to the left and found one right there, which would be negative 0.8. So you can see from the unit circle, for one y, we have two x values that would work, which is why we get two answers for the cosine. So for homework, please try to use the Pythagorean identity to find two values of the other trig ratio than what's given. So in number 1, you're told that the sine of an angle is 0.4 or 0.4. So please find two values of cosine. And in the second one, you're told that the cosine of an angle is 0.85. So please find two values of sine.